So we are starting our first of 4 keynote speakers, and it is my great pleasure to introduce to you Professor Jonker from the Netherlands. She is one of the most renowned Dutch AI researchers. AI understood over her illustrious career for many years. She's also a very nice person, and she has a very interesting talk for us. And unfortunately, she didn't come to the opening, but if she was, then she would see that her talk is in many ways continuation of our discussions of the role of AI systems in the changing world. Because we were talking yesterday about data centers and how we can make them more efficient. We were talking about AI in space. But our main conclusion was that we need to still have the old good AI, and then the modern funny things need to be used very carefully and very deliberately not to introduce bad things like hallucinations. So continuing in this direction, we're gonna have a talk, fantastic talk, I believe, about hybrid AI, and it's gonna be also, in our conference we have sort of those. We have the 5 areas, but the business informatics area is very important and well represented. And here we have this in context of organizations, which will be also, I think, of importance to those of you who are mostly from the, let's say, business informatics side of intelligence systems. So, Professor Jonker, floor is yours, and please give a round of welcoming applause.
Oh, thank you very much, Marius, for your very kind introduction, and my apologies again for not showing up yesterday evening. I want to start with a story about, say, the modern large language model-based artificial intelligence. Here we had a situation where someone was to write a report. So they were given a task and they had to write a report on their findings. And of course, you start writing a report with a bulleted list, right? These are basically the things that you have to put in the report. Now you're pressed for time. So you don't want to make the report, right? These days we have large language models. So you give it to a large language model and it writes a beautiful report about it. And you send it across to the person who asked for the report. Guess what? The other party, the recipient, also doesn't want to read a long report, right? So what does they do? They take a large language model and say, give me a summary, give me a bulleted list as a summary. Out comes a bulleted list. You think that the first bulleted list is the same as the second bulleted list? No way. Are we then wasting energy? And I understand that also the energy consumption was really discussed last evening as well. I don't think so. So maybe it's a thing to think about. In the previous session, we also, I was in room 1 here before the break. We had interesting discussions on what large language models can do and cannot do, and whether or not they're, really understand what they're doing, or it's just a token representative in the end. What I do know is they're based on all our experience over not just decades, but basically thousands of years, all the documents that we have available for it on the internet. And out of it comes a kind of, say, most probable answer. And I think we need to make sure that we're not drifting towards that most average answer all the time, because your uniqueness matters. And your uniqueness is something that has motivated me over the many years. So yes, I've been a professor of AI for quite some time, because basically I am fascinated by intelligence. All forms of intelligence. Human intelligence, animal intelligence, and yes, I do believe humans are animals, but also all kinds of forms of artificial intelligence. And so the idea of combining that to make more of it, to be smarter than we could be otherwise, is what has driven me and a lot of other people in the Netherlands to come up with a proposal for what we call hybrid intelligence. I'll tell you a bit more about it, and I hope to tell you a bit more on how I think we can use that to enhance the strength of humans and organizations. And in particular today I would like to focus a bit more on the learning capacity of organizations and the power to reflect, to monitor how good it is what we're doing with artificial intelligence. I got this nice device. Good. So maybe just to tell a little bit more about this notion of hybrid intelligence. For us, hybrid intelligence is the intelligence that emerges basically from the collaboration between humans and artificial intelligence, and in such a way that it augments what we call human intellect, and therefore focuses on harvesting human intellect, human intelligence, and to see what parts of human intelligence we can enhance. Where is human intelligence lacking, and is another form of intelligence simply better suited for the job? Well, then let's use that. But then how do you harmonize the whole thing again, so that we know what it is that we're doing? And that's the concept of meaningful human control or human oversight. Can I see some hands, please? Who has heard of this term before? Meaningful human control or human oversight? Oh, okay, cool. Now, then I can tell a little bit more about it, right? So the idea is as follows. You have this powerful idea of artificial intelligence, and you still want to know what it is that it does. And you want to be able to steer it in directions that are beneficial for us and doesn't lead its life of its own. And a nice comparison to that is maybe this image of a horse. A horse has meant a lot for our evolution, and I hope also has brought us a lot of richness and richdom, and allowed us to carry weights far beyond what we would be able to do ourselves, and pull weight, move faster. So it's a nice parable, I would say, to compare it to artificial intelligence. So this horse, as you see it on the picture on the left, has some reins on it, and also with their legs and their seat, the human rider can more or less steer the horse into the direction that they want at the speed that they want, if they're capable riders. You have to learn how to use it. Maybe that's also something to take into account when thinking of using different forms of artificial intelligence. Do we still understand what it does, and can we control what it does? Okay, now interestingly enough, this horse, or horses in general, can jump higher with a rider, even though they weigh like 70 kilos or more, than a horse without a rider. So I'm not so sure if the horse would be really from itself so interested in jumping so high, but it can. So if we're talking about capabilities, there's an added value to the horse as well. Right? Now, on the other hand, these reins that you see are not all determinant. If suddenly an object comes across the road that the horse is on, the horse will try to avoid that, either jump or brake or do whatever it has to avoid a collision. If you as a rider still have to think about it and communicate that, you're too late, right? So it will do something, and then it's your job as a rider to stay on. And the same you see on the right-hand side. It may be even more impressive aspect of a collaboration between human and horse. You see there what is called a cutting horse. The job of that horse is to cut the cow away from the herd. The cow wants to be in that herd. There's safety in numbers, right? So it doesn't want to be separated. Now the horse is a herd animal, understands these motivations, and can very quickly adapt to the jumps that the cow will make to try to regain or rejoin the herd. If as a rider you have to communicate, now go left, jump right, be faster this way or that way, you're simply too late. It's impossible. So if you look closely at that picture, you see also reins on that animal, but the reins are slack, completely slack, because the rider needs all his powers to stay on that horse. It's moving so fast. Still, the rider determines which cow to separate from the herd and when the job is done. Now, the other next interesting point is that the experienced rider teaches a new cutting horse, but an experienced cutting horse teaches the next rider, the new rider. So can we learn from each other? And I think if you start seeing that as an organization in which you have different riders, new riders, old riders, all kinds of horses, they form one organization. Can they teach each other? Can we together learn more and therefore accomplish things that they otherwise wouldn't do? And that's the idea of hybrid intelligence. And included in that is the idea of meaningful human control, in the idea of making sure that we still know what's going on and we have some grip on that. So what I'm looking for in terms of learning, or maybe even a co-evolution between humans and artificial intelligence, is that mutual learning. Right? We learn from each other, we learn the new generation of algorithms, and we teach the algorithms teach new generations of humans. Hopefully up to a way that brings the whole organization to a higher aspect of capabilities. So in order to do that, what do we need? As I said, you can just see it as this cutting horse example. You learn from each other while on the job. But on the other hand, humans have something which is also very specific, and it's called reflection. And I think the time is there to take that reflection more seriously. When putting AI in different components or different parts of your workflow in organizations, you need to keep a good eye on what it's doing, and you need to adjust regularly. Because the data that you trained your algorithms on might not be the data, doesn't meet the same properties as the data that is now being fed into the algorithms, say a few years down the line. Right? Circumstances will have changed, the conditions will have changed. In the meantime, new algorithms might have popped up that actually do the job better. You need to be able to reflect on that and supplant them with other ones when the time is there. So I think we need more reflection over and with AI, which is a means of creating this meaningful human control over artificial intelligence. So a picture that I think you will hear more frequently as time goes on is that all these different forms of intelligence that we have in AI have their own uses. And see it like the tools of a carpenter. Let's not just go for one trick and think that one algorithm or one type of AI does everything that we need. Use all the tools that you have in your trade and combine them in a wise way. It's more suitable. So in that way, you see, you can use black box AI algorithms because maybe they're, on general, more effective than some of the more knowledge-based artificial intelligence methods or symbolic AI methods. But on the other hand, the knowledge-based AI methods allow for a better introspection of what is going on. So can we use the same type of algorithms that we use for knowledge-based machine learning, so symbolic machine learning, over black boxes to learn what these black boxes actually have in their system? So basically making a model of a model. Well, you've all been modelers for I don't know how many years, depending on how old you are and how long you're already in the trade. You know what it is, how difficult it is to model, right? But you can use model of a model in a smart way. So this picture is there to illustrate that different forms of AI can be used to reflect together with humans on what the quality is of what we are actually doing. And if we get that more into play, then you can also start saying, okay, now we need to change some aspects of this. So let me give that an example from sequential decision making. With some colleagues, in particular Anne Way and her group, with one of the PhD students, Alexandra Simpian, we've embarked on studies on can we make sequential decision making more fair? Can we introduce fairness notions into reinforcement learning to improve that part? So there are three aspects here that I'd like to come back to. Of course, this notion of meaningful human control. So how fair are our decisions? Do we need to change some stuff? Which requires monitoring how good we do that. And of course, how can we use that knowledge to then improve the learning algorithms to be more fair, right? Okay, so basically what I'm talking about in the same type of setting is that you have your AI algorithm, in this case for us reinforcement learning. You have your input streams, input databases, and you have your output streams. I basically want to make sure that we monitor all of it. So what is the quality of the data that goes in? What is the quality of the decision making of, say, the black box AI? And what's the quality of the output, right? So can we put AI on top of that? And for that you can, of course, start formalizing some notions, some properties on what it is that you're interested in. And for us, that is fairness. So now, two examples. You have job hiring and you have fraud detection. Interestingly, different problems for which we happen, of course, to have the data. If you don't have data, you can't do your job, right? Okay, so in job hiring, we all know it. There's been a lot to say and still being said about fairness, inclusivity, underrepresented groups, all these kind of elements. So there is a historical bias. How do you deal with that? And how do we create equal opportunities for everyone? Both in promotions, but also in being hired. This is, well, the part that is really first about hiring. And in fraud detection, completely different type of example in terms of the insurance that we have if fraudulent transactions are being made. Of course, banks and of course also your clients are very much interested in fraud being detected early. So think about fraud with credit cards or phishing emails and so on. Now, for both of these, the interesting point becomes what's the difference between individual fairness and group fairness? And that's what I discuss in a bit. Now, maybe one more thing about fraud detection. On the one hand, you want to be sure that a fraudulent transaction is caught. On the other hand, your customers get annoyed if they are checked too often on transactions that are not fraudulent, right? Because it is a hassle. Okay, well, who doesn't know reinforcement learning? Good. Okay, so you all know reinforcement learning. Nice. Now, you know the standard aspect of you have your reward function and you compare that with your state S, and based on that you pick your next action, you get a reward, and that's how it cycles. And over time you hope to improve your policies towards reaching a better reward. Now, if we're talking about fairness, then that's one part of human life. We don't all agree on what fairness actually means. And so there are different people coming with different aspects of fairness. So you can have all kinds of notions on what group fairness means. And you can have individual fairness. And there the same thing holds. So people want to be treated individually fair as well. So once you start thinking about these aspects, you get back into the old-fashioned knowledge technology in terms of how do we model what fairness is. Now, maybe LLMs can play a role there as well. Maybe they can come up with a first formalization. And I think Marius Kaleti, if you're there, there you are. Yes, exactly. You were talking about things like that. And I think these are interesting notions of how we can use the different types of intelligence in a proper way. So that's an interesting point to consider. And then, of course, well, you can add your fairness criteria to your feedback signal, right? That's one aspect. You can just add it to the feedback signal, or you can just use it as a monitoring. So you can give a fairness signal as a reward function to the reinforcement learning algorithm, but you can also still monitor on how fair it is with respect to other notions of fairness. And as I said, there are many notions of fairness. We found a couple of them in the literature on group fairness, and I'll just go over 2 of them, and I'll don't bother you with the rest. It's just the idea of it. So statistical parity says that people from 2 groups that you're comparing are hired with the same probability. And the equal opportunity says something about, well, they should be qualified, right? So if we're talking about hiring, so qualified members of both groups are hired with the same probability. And so you see all kinds of modifiers coming in. Of course, there's more notions that you can think of. Whereas if you think about individual fairness, then basically we're looking at the probability distributions for the actions for these 2 individuals, X and Y, at a certain time t. Then these probability distributions over the actions should not be larger than the distance between those 2 individuals to start with, say on their characteristics. Of course, then that means then what is your distance function? So again, you run into the same aspects of modeling what that distance is. But anyway, here you have like 2 notions of individual fairness, and that means that once you have those in place, you can start interacting with your knowledge-based system on top of your reinforcement learning algorithm to see how good it's doing, and if necessary, to steer it more. And that gives you an opportunity for what the MHC stands for, is meaningful human control. So it's an example of how you can put in place meaningful human control, and a notion in which the human intelligence on what actually is going on also gets a place in that system. So it's a notion or an example of how you could see this as a hybrid intelligence system. Okay. Now, in this case, I'll skip the one on the multi-objective reinforcement learning and the Pareto conditioned networks, but I think the most important ones is now to consider the point of so what happens then if you do that in these 2 different case studies, job hiring and the fraud detection. Now, interestingly enough, here you see the effect of it. This is for job hiring. You see on every radar plot, you see the letters for the different fairness notions. So the R stands still for the original reward function. Say the productivity of the team which hires a person. And then you see SP for the statistical parity. And on the right-hand side of that radar plot, you see IF, the individual fairness notions. Now you see also here that individual fairness is a really difficult thing to model in systems. It's very difficult to ensure individual fairness per person. But you also see how it varies over the different plots that you make with it. So focusing on one aspect, so the blue ones are the ones that are given as a reward function, as part of the reward function, the feedback signal. The other ones are just measured. And there you see that sometimes things have an effect also on the fairness notions that you did not intend to be affected by it. As well as on the ones that you try to optimize for. So overall you see here that these different individual notions are relatively more difficult than the other ones to optimize. But you also see that it's possible without losing so much on your reward function. Now of course that will be in the end a debate. How much do you lose on your reward signal? And so how much is it worth to you that you make fair decisions? And that means that that's a human decision, right? That's something for the organization, for the board, for the whatever people are supposed to make decisions about the organization that you're part of. In terms of fraud detection, you see that the reward signal in general is difficult there to achieve well. And you see more variation also on some of the notions of group precision or group fairness. So in terms of, let's do a reflection on what we did. If you try to combine fairness and machine learning, then yes, this monitoring of fairness notions is something that I think we should do. And not just fairness, you can think of all kinds of other properties, ethical or otherwise, that you'd like to add to your machine learning element, that you learn from the monitoring results. And basically that allows you to adapt either your algorithms or the fairness notions or other ethical properties that you have. In terms of technical aspects, yes, the work is not completely done yet, and there's still some interesting challenges. So how long is, say, the time window that you use to evaluate your fairness? If you compare to historical data, well, if your history was biased, then that will have an impact on your current decisions as well. So how long are you going to be punished for things you did in the past? Well, these are elements to take into consideration. And furthermore, technically also, bringing along the full history is just simply intractable. So a sliding window is important. Can we use another neural network for approximating how far along, how far in the past we should look? Or can we approximate what the full history should look like? Can we model that differently? And as I said, the formalization of all these notions, properties, are not trivial for lay people, so we should help them. And can we use other forms of AI to do so? And what then is the effect of that on a learning organization? If we're considering the learning organization, then there's some interesting literature on it, and basically says, how can we ensure that the knowledge within your organization grows and is not reduced by people leaving the organization? So typically your human capital in organizations is really very important and determines the uniqueness of an organization. So if we reflect on that with combining AI in a hybrid way with artificial intelligence, you want AI to amplify the unique strengths of your organization. That's what would give you the competitive edge, and not just all of us deploying a chatbot for our customers or a bot that helps you read your emails. Of course you have to do that, but the others are also doing it. So that's not something that will bring you a competitive edge. So how can we facilitate with AI the learning at an individual level, at a group level, and how can you do that at the organizational level? So for that, I'd like to move on to an example of the Legal Desk, which is an organization in the Netherlands which provides free legal service to people that got into conflicts with their government, with our government. And so the way that these people operate are very much client-central. So they're looking at their problems and try to give them the best access to justice that they can get. Also means that typically they have to do a broad diagnosis. People typically don't come in with a single problem. There's a multitude of problems that comes up. Now we work together with a part of that organization that looked at immigration law. So you'll see some examples from there as well. Now, if you look at the organization, you can bring in, say, different layers of within that organization. The micro level, where the legal advisors are talking with the clients. You have the management layer that looks at what is going on within that advisory studies going on. And of course, the organization has to work together with other organizations. Now, if we're looking at the workload of the legal desk, then the amount of problems that they were facing, so customers coming in, grew by 148%. So it really went from 15,500 in 1 year to over 38,000 per year. Other than that, it's an organization that doesn't have a lot of money. So young lawyers come in, do that a couple of years, and once they have enough expertise, they leave again to earn more money at other law firms, right? So in general, the number of advisors hasn't grown, even though they tried hiring more, and the number of experienced advisors is also not growing. So, yeah, how to deal with that? Now, what is exactly then the problem of a learning organization? And I already addressed that. Part of it is that young lawyers are less experienced. The seniors know what to ask when. And that's basically the gap between the expert and the novice. So the expert has a map of, say, the law in his mind, knows how different fields of law are connected to each other, and can connect that to a broad diagnosis. But for the novice, basically still looks like bookshelves, right? They have studied each of these books, but they don't exactly remember what, when, where was in each book. So they have to dive into each of them, trying to address a single aspect, and then see how they can combine that with the questions that the customer is asking. So that means that in the end, basically, this is the picture. You see that the less experienced advisor works with something that we would model as decision trees, and the experienced advisor works with something that we might call a decision forest, having a map of that forest. And so how do we capture that experience? Now, of course, you'd like to use reinforcement learning, machine learning. So where's the data? So if you look at the data of all the cases that I've covered in their past, what is stored is the initial problem that they came in with, plus the advice that was given, and that's it. But there is no way that correlates to each other, because you have to ask the right kind of questions, context questions, for the advice to fit. So how do you get to that context? And I think that in general is the problem that we're facing here. Now, if we can harvest some way, if we can find a way in which we can harvest the knowledge of senior advisors on what question to ask when and why, then we can use it to teach the youngers with that, and we can store it in a way that is accessible to the organization and as a whole, and you would grow a learning organization. So in the old days, it basically went like this. You have experts that teach the novices. They have classes for that. You go over a couple of cases and you hope that they learn over time. Takes about 3 years to grow from a junior consultant into a senior consultant. Can we speed it up with some artificial intelligence? Some way to exploit that knowledge of the seniors, put it into a learning tool, give the learning tool in such a way that, make it in such a way that they can actually use it when sitting with their clients, also for the junior consultants. And do novices actually learn from that? Does it help? Does it speed up that information? Now, of course, then, since the law changes and circumstances in the world change, new problems arise. So you would also like to reflect on that new problems. So you also would like to get new knowledge out of people. And that's how you then in the end close the loop, because you can start a signaling function within this monitoring tool. Say, hey, this is a case that we haven't seen before and which the previously stored knowledge doesn't give us the answer. Can we talk about it? Create the new piece of knowledge, put it into the system and let it run along. And of course, once you have it, you can also start applying machine learning algorithms, because now you know what questions people ask and why, and what is the strategy of the senior advisors, and can you harvest that? And with that way you can close that loop, so you get this kind of infinity aspect into it. So in terms of the learning organization, you have a couple of design principles. So you want to add stuff. Integrating human or artificial intelligence should improve the intelligence of the organization. Interestingly enough, replacing human intelligence with AI does not necessarily lead to a more intelligent organization, and it's also not unique, right? Relevance. The type of intelligence must match the nature of the task. Yes, seems obvious, so why don't we do that? Make use of the diversity that you have in your teams and go for collaboration. Organizational intelligence requires collaborative skills from both humans and artificial intelligence systems, because if you want to do this kind of reflection that I've been talking about, your AI has to have more social skills than they currently have. They have to start forming things like a mental model of what other people can do. Say, a theory of mind, even for those who know about it. And of course, your explanations have to be up to par. So, in a hybrid learning organization, we have to add the point of this human oversight or meaningful human control. And you have to add this point of collaborative reflection. And that ties in both aspects back together again, so that in the end, if you're looking at the this infinity process, you have to think about how to activate these different pathways through this model. How do you go from the abstract to the concrete? And how do you go from the concrete to the abstract? So how do you extract knowledge that can do that? The only way in our mind that you can do that properly is through co-creation, which also brings you the buy-in of the people that have to work with the whole thing. So, in summary, you could say, well, the broad diagnostics are then a field where you say, okay, we have brilliant, interesting stuff on, say, generative AI, large language models that can go through all the documentation on the web, but they don't know the context of the people that it's supposed to work for. So you're in your organization, the key knowledge that you have is how to get to that contextual information. And that means that in your design thinking, you have to make sure that you co-create it with people to a way that brings out the best of both types of intelligence or multiple types of intelligence. In this case of the legal desk, we did that with something which is called a canvas. I heard that there are quite some people from with a business context in their pocket. They know what the canvas is, and it basically helps you think about what type of questions to ask. Then you might ask, why not just simply do it with ChatGPT or another large language model, which is a simple way of really replacing the humans in the loop, right? Let's go throw out the consultants as a whole and just feed the question to the large language model. And just this is to illustrate the idea of what happens in those cases. So a client comes to the counter, has worked for his employer for 2 years, he has a contract for 10 hours per week, but has been working an average of 40 hours for the past 6 months. The employer told the client he will no longer be scheduled. What can the client do? So he's worried about his legal status. Well, ChatGPT comes with an invocation of what is called a legal assumption or presumption of working hours, which says that if you have worked structurally for more hours than stated in your contract for at least 3 months, then this provides a normal reflection of the normal pattern in that work, then you have a right to now be scheduled and also for 40 hours. So you actually have the right similar to someone who has a contract for 40 hours. And that's what it will reply, but that's not all of it. You need to know much more about the context. What did the employer do? What is the normal type of work going on there? So if you just give this back to the client, you feed expectations that will be disappointed in many of the cases, and that's not fair. So anyway, to come back to the canvas, we made it into a system that also lay people can now modify. So that means the lay people from our ICT perspective. So the senior people can create a new canvas for new experiences that they have. And if you compare that to what comes out of the ChatGPT's response, we did find a use for it. But with the senior consultants know which parts make sense and which do not make sense. So if we combine the power of the large language models with that of your senior consultants, you can create a new canvas, and with that, or more easily create a new canvas, and with that give a boost to your learning organizations. So in terms of thinking about it, you should always look further along in your organization than just the point where you want to put the AI. You want to see it in the broader context of the overall workflow and know at what points in the normal workflow does this have an effect. And this is what is described here with these 3 circles. So within the legal organization, they also have the education for younger consultants. You see in the consultation, they can interpret the case and discuss then, if necessary, with colleagues, choose the right canvas, use it, give the advice, but also give a signal like, hey, this is a new experience for us. This is a question we have never seen before. How should we deal with that? And that leads you to the last circle there, which is intervision, human aspect in there, where the people together determine what should be done there, feed that back into a canvas, and the circle is being closed. So the legal desk as a learning organization was co-designed. It anchors reflection, it collects new knowledge, and integrates knowledge transfer in these systems. And I think that is a general aspect that we'd like to see happening. I will skip this part about the more that we did with the large language models and go to my summary, last slide. Basically, as a summary, we'd like you to design for hybrid intelligence because we think these aspects of meaningful human control are important. That helps you to augment human intellect and human uniqueness. And with that also increases the competitive edge for organizations. The context awareness is essential as humans bridge the context to the generative AI aspects, bring in reflection and transparency, and boost the learning capacity of your organization by system thinking. I think with that I'd like to conclude. Thank you.
Thank you. This is really cool. But I have some questions, comments, but I know that I overused my time for comment last night, so I will let other people who would like to comment, ask questions. Please raise your hand. We will have microphones. Okay. Then I would like to go back to fairness, because while I really like to have fairness, I have a contextual cultural problem with what fairness is. And I am afraid, really afraid, that what is fair and appropriate in one community, I'm trying to be very nice and delicate here, may be controversial in another community. And let me put it this way. Some things which would be considered fair, appropriate, and the right thing to do in the Netherlands, if you move, let's say, I don't know, some place into another continent.
Let's call China, for example.
We could use, or North Korea, maybe even.
Yes.
Or North America, Wyoming, so consider Wyoming or North Dakota, would be very much not considered fair and appropriate. So how can we even talk about it if it seems to be contextual and society and community based?
Yeah, well, that's of course exactly the point where you need to talk about it. And if you look at this picture of an organization in the scope, in the context of its surroundings, then of course what is fair in one organization or in one country is not the same as fairness in the other. So you need to talk about it and you need to discuss it. And that's a human affair. And so let's by all means not go to a situation wherein AI determines what is fair for us. So the whole picture that was depicted in the first part of the organization, of the talk, was to make sure that humans determine what is fair, and humans within that organization, but maybe also the humans in, say, a country or in a bigger conglomerate of organizations collaborating together. So yes, it will not solve the thing automatically, but it will trigger a conversation. And I think that's a conversation that determines our uniqueness as humans and is something that we should solve ourselves. So yes, the formulation we can help with, the formalization, but the real human conversation should be done by humans.
Okay, who else would like to ask a question? Okay, we have two. Microphone is going that way.
Thank you for the talk. I was just curious about how you reach the optimal solution in the multi-objective framework about the fairness. Is a kind of scalarization or lexicographic approach, or?
Yeah, so indeed it adds to the reinforcement signal and has to be taken into account. So you You feed it with the data you have over the past, you comment on it, and you make sure that that signal goes back into your policy making, policy learning aspect of your, in this case, reinforcement learning, but might be something else as well. Yep.
So the solution you show us in the charts were the Pareto optimal.
Yeah.
Okay.
Of course, if you train long enough, then yes. Yeah.
Okay. Thank you very much.
Yeah, thank you. I also want to ask, maybe I want to share my thoughts about the fairness, this reinforcement learning. I just, during your presentation, I just had that thoughts that, maybe there are some similarities to social choice theory, like maybe even famous Arrow's impossibility theorem. There is fairness, there is that. Maybe I'm simply curious if we can take something from that field of science and apply that. I will give you an example, talking about this hiring people, for instance. So the very first solution would be that everybody will get the worst job because everybody will be treated in the same way. Everybody will be unhappy. But of course, there is a cost that we call cost of fairness. And so this theorem says roughly, let me simplify that we cannot have efficiency and fairness maybe at the same time. So I just want to share my thoughts that there is another field and maybe we can learn or we can take out of that field and apply to that. Maybe you have some comments.
Let's do that. Yeah. So no, definitely. So exactly, this is what I hope to achieve, that by using different forms of artificial intelligence and all the work that we've done also in game theory and in of course social choice theory, that we make that more accessible to people. And people find it difficult to think about abstract situations in general. But if we can feed them with the results of going on within their organization or the outcome of a certain election, and then make it connected to these different theorems, you can show what's going on, and it becomes something that's tangible, and therefore something that people might want to act on. And yes, this is only creating more work for us, but on the other hand, maybe that's also what we need, because AI is taking over some of the jobs that we were doing in the past, right? So maybe it's an opportunity.
Okay, somebody else? Okay, so I just have a comment, in one of the slides you stated that AI can be used to speed up the process of knowledge transfer from those who know to those who have to learn. And I recently listened to a podcast about something completely different, in which a musician was stating that there are some musicians who jump to fame too early, and they didn't fully develop through all the steps, which means that when they are in this moment of fame too early, they didn't play in small clubs, then a little bit larger clubs, then a little bit larger venues. They didn't go through the pathway because they were able to, because of some weird moment they became famous. Then this can have negative effect on them because they didn't experience enough of various situations to fully develop as artists. And this hit me that we are living longer and longer, which means maybe this constant message, you have to achieve everything faster, you have to do things faster. If you are not using our device that will make something faster for you, you are not competitive. Maybe being competitive and doing things faster is not a good idea, and maybe we should, as a matter of fact, do things slower and more judiciously to fully understand where we are going. But it's just a comment. It's not, it's just, why are we trying to get faster?
Yeah, well, I love that comment, and I think it's a discussion that we need to have. Are we really optimizing for the right thing? Is efficiency always the thing to optimize for, or are there other values that we should look at? And I would say yes. So I love this kind of comment, and I think I hear it more often these days than say 10 years ago. So yeah, I think this whole revolution that AI is bringing also challenges us to think about what we find really important in the long run. And well, the discussion yesterday also on electricity and energy consumption is one like that. You know, do you really want to ask an LLM about what the meaning of a certain word is, where you could do the same query to a normal browser with what is it, a 10th or so or 20th of the energy consumption? You know, yeah, you use the right tool for the right job.
Okay, anybody else? Okay, if not, Professor will be with us for a short while. When are you leaving?
4:15.
Okay, so over lunch,
Yes,
you can catch Professor Jonker and talk to her and ask her the more intimate, private questions that you don't want to be recorded for posterity and used to you know, to be fed into some multimodal LLM training by evil American companies. So you can do it privately, and then it's going to be between you. Thank you very much, and let's give a round of applause to Professor Jonker.
Thank you so much.